The first part of X-ray, we look at how X-ray is produced. We accelerate electron through a potential difference, so the kinetic energy becomes EV. E is the charge on the electron, V is the potential difference is being accelerated through, and it hits a target. And in the target, the electrons are decelerated and X-ray is produced. So if we think of X-ray as particle, so if the electron give all its energy to produce the X-ray, then we have the minimum wavelength or maximum frequency. Okay, so today we are looking at the second part. First part, we look at how it's produced. Now we look at how we use the X-ray. Okay, the key important thing is diagnostic. We want to be able to see the different structure in the body clearly. Okay, the first thing about X-ray is penetrating power. Penetrating power is the ability of a radiation to penetrate matter. The greater the energy of the X-ray photon, the further that they will be able to penetrate through a material before being completely absorbed. Quality of X-ray is the hardness of the X-ray. Quantity of X-ray is the intensity of the X-ray. Hard X-ray are X-ray with high penetrating power or high penetrating power and hence high photon energy and frequency. Right? So usually the accelerating potential is between 100 to 150 kilovolt. Used to investigate bone structure, okay, like this case. Hard X-ray are attenuated by bone tissue but suffer little attenuation by soft tissue surrounding the bone. Right? Attenuated means it lose energy lah. Right? Or absorption or reduce in amplitude. Right? Either it lose an energy or it lose in amplitude. If we think it as waves. Soft X-ray are X-ray that have much lower penetrating power and hence lower photon energy and frequency. Right? So the accelerating potential is 50 kilovolt. They have longer wavelength. Right? Less energy, longer wavelength. Soft X-ray that are unable to pass through the patient contribute to total radiation dose without any useful purposes. Right? Usually soft X-ray, we filter it off lah. They have no useful purposes other than contribute to the total dose lah. Unnecessary lah. So soft X-ray removed by aluminum filter. An aluminum filter is frequently fitted across the window of the X-ray tube to absorb the soft X-ray photon. Used to make image for some soft tissue, example, growth of liver. Soft X-ray give much greater difference in relative attenuation of X-ray by different types of tissue and thus better contrast between two images. Right? This is before the 20th century lah. Right? People are still modest. For info lah, it won't be tested. Right? To me, I think it's important to learn. Since you learn X-ray, you must learn what is the side effect. It's desirable to limit exposure of a patient to X-ray, as X-ray are ionizing radiation. Right? You want to keep the dose that the person is exposed to X-ray as little as possible, so that exposure to harm is as little as possible, which can damage, right? Ionizing radiation can damage or kill body cells. Ionizing radiation is a beam of high energy particles that can remove one or more electrons. Right? In this case, remove an electron for the nucleus. Right? These are just pictorial form to show you. Right? This one, if you remove this electron, then the other electron from the top energy level will come down to fill the place. Right? Or it can cause promotion of the electron, excitation to the higher orbit. So either case, ultraviolet is emitted, or ultraviolet, in this case, ultraviolet is emitted when it de-excite, or in this case, ultraviolet light is obtained, cause excitation. Removal of one or more electron from an atom in its path, example, X-ray. Ionizing radiation causes both excitation, this is the case of excitation, right? Promoted this electron to a higher energy level, and ionization, where this electron is lost completely. In this case, in ionization, the atom is separated into two parts with equal and opposite electric charge, so-called ion pair. Right? The nucleus of the atom become positively charged, and then the other one is the electron. Right? So you got positive ion and negative electron. The most common ion pair is electron, and the remainder of the atom, a positive ion. Okay, I think I will let you read yourself this one. In this process, molecular bonds may be broken and abnormal chemical reaction induced, although many such changes are transient and of no biological significance. Some are temporarily of no significance. Okay, that's the side effect lah. Leukemia, cardiovascular disease. Okay, that one you can read yourself during your free time. Okay, basic setup of X-ray. Right? Your X-ray source. We summarize it lah. The target there will produce X-ray, and then we use a collimator. Right? Control the aperture. Aperture is just basically a hole lah, or slit for the X-ray to pass through. Then there is the anti-scatter grid. This X-ray film. Right? Photographic plate lah. Right? This is a X-ray picture of the rib with the lung. Right? Chinese surgeon saved a man's life after accidentally swallow a pair of nail scissors he has using to clean his teeth. I don't know how he get the scissors into his throat. Okay, how an X-ray image is produced. Right? This is your tissue, let's say, and there's your bone, different color, and there's your X-ray film, photographic plate. As the X-ray beam passes through the body, part of it is absorbed, the rest is transmitted. Right? This is a parallel beam. Right? This one is passed through the body, passed through the tissue. Some of it is absorbed by the bone, doesn't pass through. This one pass through the tissue again. Image obtained is a shadow of the tissue. Or taking picture is the negative lah. So this part where it's exposed, it will be black when developed. Same as this part where the X-ray can pass through, black when developed. This part where the X-ray doesn't pass through will be white. X-ray beam can penetrate soft tissue, example skin, fat, muscle with little loss of intensity. Thus appear as dark area, right? Dark area, black. On the photographic film, both bone causes greater attenuation, right? Loss in amplitude or loss of energy, and soft tissue, and will appear as lighter in color. Right? You can see that the bone are lighter in color on the film. What is produced on the film is a two-dimensional shadow of the bone and the surrounding tissue. Right? Just one picture only, you expose it very fast, and it's two-dimensional shadow. Right? This CT scan, which we will study later on if we got the time today. There's the X-ray image. Image produced on X-ray plate as outlined is a flat image, two dimension. That's why it means flat. Does not give any impression of that. It doesn't show you the relationship between one tissue and another tissue. That is whether an organ is near the skin or deep within the body is not apparent. Right? When it's two dimension, all of them are all more or less the same distance. Quality of a shadow picture, the image produced on the photographic plate depends on its sharpness and contrast. Right? Sharpness is normal in the syllabus, but we just go through just for info lah. Contrast is still in. I think X-ray has been greatly reduced. Right? This is for info, sharpness. What is sharpness? Sharpness is with which edges of the pictures can be seen. Right? See the edges there. Or in sharpness, clear distinction between boundaries. Right? There's your finger, the bone of your finger. This one is not so clear lah. How to obtain sharpness in film? The source of X-ray must be a point source or give parallel X-ray beam. Right? That's important. If you want sharp image, the source must be a point source and give parallel X-ray beam. Right? That's a point source of X-ray. Or it's a parallel beam who give full shadow. Point source, object, right? That's your body that you want to X-ray. There's the X-ray film, the ray of light, ray of X-ray, the pass through, that pass through, the cast a shadow there. So that will be your shadow. Right? Unfortunately, our target is not a point source. Right? Our target is the extended source. Right? Extended source. In order to achieve as sharp an image as possible, the X-ray tube is designed to generate a beam of X-ray with minimum width. So we will control it lah. As it comes out later on, there's the window. So we can use collimator lah. Right? That's where X-ray is from the extended source coming out in this direction. And this picture show you, right? If you extended source, this is a point source, right? Point source, you can see the very clear shadow. Right? Extended source, you can see the blur penumbra, right? Shadow in the penumbra there. Okay, this picture will show you. Right? There's a shadow, there's a subject, object to be X-ray. If you have a extended source of X-ray, there's a point source, then it's very clear. That one you have a penumbra there. Factors in the design of X-ray apparatus that may affect sharpness include, right? As I said, this is for info. Area of target, right? Area of target or anode lah. There's the extended source there. Size of aperture, right? Size of aperture will be controlled later on by collimator. Right? This is produced by overlapping metal plates through which X-ray beam passes after leaving the tube. Scatter X-ray, use of lead grid in front of the photographic film to absorb the scatter X-ray. Okay, right? This is partial shadow. I make it not so sharp. Same here. This one is a greater area for the target, so you can see the partial shadow is larger. So the way to control it to have an aperture, put a collimator there, a metal plate, narrow the X-ray coming out, limit the X-ray coming out lah. Right? So that is the aperture lah. Effect of the area of the target anode on the sharpness. Reducing the area of the target reduces the partial shadow. Okay, you reduce the partial shadow by decreasing the aperture. Limiting the size of aperture through which the wind passes. Okay, you cut off the partial shadow lah. Right? Either we limit the area of the target or we have an aperture, smaller aperture. Right? These are metal collimator. Right? This is the aperture. This is a collimator. Right? That's a collimator. Overlapping plate. Size of aperture can be adjusted by overlapping metal plate through which X-ray pass through after leaving the tube. Right? All this for info lah. Scatter. These are scattering. Instead of going straight through or being absorbed, we scatter there. Same here, scatter there. So with that, we put lead grid, right? We absorb the scatter, so it won't come out. Use of lead grid in front of the photographic film to absorb the scattered X-ray photon. Okay, this is what we are more interested in. Page 299, contrast. Contrast, difference in blackening between structure. Remember that, difference in blackening between structure. Contrast is due to large differences in blackening of different region and is caused by difference in attenuation. Attenuation coefficient. Okay, so basically there's a difference in brightness between light and dark area of the image. Right? This low poor contrast, this high contrast, this optimum. Contrast of the image produced in photographic film is affected by exposure time. Right? This one been exposed long enough. X-ray penetration, scattering of X-ray beam within the patient's body. Improving contrast. In order to improve contrast, a contrast medium may be used. For example, the stomach may be examined by giving a patient a drink of containing barium sulfide. You want to investigate what is wrong with the stomach, like myself complaining about farting too often, uncomfortable feeling. So doctor, let me drink barium sulfate, and then X-ray the stomach. So they can see there's something there. Or we want to outline blood vessel, a contrast medium that absorb X-ray, that absorb strongly the X-ray will be injected into the bloodstream. Contrast may be improved by backing the photographic film with a fluorescent material. Okay, always remember the formula is same like radioactivity. This is your decay constant given in your data sheet. Okay, attenuation of X-ray in metal. Right? We think of it as particle. X-ray photon is attenuated, is absorbed by the object or medium, and then those that pass through is penetration. Attenuation of X-ray is a degree of absorption of X-ray by the body tissue, or we can say as decrease in energy or in amplitude. Okay, if the examiner asks you what is linear absorption coefficient, basically you have to write this whole thing. This for radioactivity. Right? You just change the symbol, that's all. Instead of N, you use I. Instead of lambda, you use mu. That's all. You're supposed to remember this formula, recall and use. Right? So that this whole slide define for you what is linear absorption coefficient. There is your I naught is the initial intensity before it goes into the tissue or absorber. Then mu is a linear absorption coefficient. X is the thickness of the tissue or absorber. And then I is the intensity after passing through the absorber. For parallel beam of radiation, that is parallel beam. Intensity of radiation after passing through, that's the intensity after passing through. Mu naught, mu is called the linear absorption coefficient. Right? It's the same as lambda in the decay constant. And it's usually in per meter. Unit is per meter. Yeah, X is in meter. So it must be per meter. Half value thickness is for your info. Right? Same as half-life lah. Formula is the same as half-life. They will not ask you what is half value thickness, but they can tell you if they what is the value meaning of half value thickness, and then ask you to calculate. Half value thickness is the thickness of the medium to reduce the transmitter intensity to 1/2 of initial value. It's a constant. right? Ln 2 or 0.693, ln 2 or mu, half value thickness. Same as half-life lah. Different type of tissue absorb X-ray to a different extent. Right? Same as half-life as radioactivity. Any comment or anything that not clear? Remember, you are muted.
Okay.
Attenuation of X-ray, right? It's exponential decay lah. Some approximate value of linear attenuation or absorption coefficient. Right? Copper is about 7, water is 0.3, bone is 3, fat is 0.9. This is a property of the type of absorbing material, right? Whether it's copper or water. For example, bone is better absorber of X-ray than fat or flesh, so it has a higher mu. Right? Copper also have higher mu. It also depends on the energy of the X-ray. You can see that this is just for info lah. No need to go too detailed about that. Right? Absorption coefficient depends on energy of X-ray use. This is the energy of X-ray use. And we can see that these two are quite small for bone and muscle. Right? This is for bone, this is for muscle. But at 50 kilo electron volt for the X-ray, there's a lot of different. Even this is double, it doesn't vary, doesn't change much lah. Same like this one doesn't change much. This one is about 6 times. Right? This is about double. Mu depends on energy. Right? Can be seen for that. As energy increases, mu decreases. Energy increases, mu decreases. Both right? Whether bone or muscle, as high energy is more penetrating. Low energy X-ray is better to differentiate. Right? Low energy, better to differentiate. Same as here, 3 times. Here is about less than double. Here is about double. Between bone and muscle, right? Low energy. You can see the difference, the great difference. Low energy X-ray is better to differentiate between bone and muscle than high energy. Right? Give you good contrast. For 4 mega electron volt, this one, the difference in mu is not significant. Right? Both of them are quite low already. Attenuation of X-ray by different tissue depends on density of tissue, thickness of tissue, atomic number of elements that make up the tissue. When a beam of X-ray passes through matter, such as a body tissue, energy is given to the tissue and intensity of the beam is reduced or attenuated. Right? As shown in the picture there, we got less than 10 minutes left. Right? Okay, the X-ray is attenuated. Energy is lost in the tissue. Okay, this is just for info. Explain the principle behind the use of X-ray for the imaging of internal body structure. Memorize.
The X-ray penetrates.
X-ray beam directed through a body onto a detector. The detector is usually a plate. Different tissue absorb beam by different amount, giving a shadow image of structure. In contrast, large differences in blackening of different region due to differences in attenuation coefficient. In sharpness, the edges can be clearly distinguished. Okay, just memorize this one. If the exam come out, any comment?
No.
Okay, no need to go and derive lah. During the break, if you can try some of the question, right? That's the mu, that's the k lah. We just differentiate it lah. Right? That's the formula. As long as it pass through, there's a exponential. It pass through exponential. This I naught. Right? Before I enter, this is why it comes out. Okay, so this one summarize for you what we have just done.
Sure.
Yeah,
Just got back my AS results.
yeah, forgotten your results should be out. What do you get?
They didn't they put my physics as not available, something like that.
How come funny, right?
Because what's it called? It's called no result.
No compulsory, paper 3.
No result means because of the practical.
So can you do practical alone by itself, or you have to do the whole AS, the 3 papers
I
all
think must
together?
do the whole S again.
Huh?
That's why I'm telling you.
Oh, by that gone no results, I thought you can just repeat your practical.
Oh,
Oh, that means it's compulsory. I thought it's not compulsory for you. Even if you miss a paper, if your grade is acceptable, you pass already. It will give you a grade. Funny. This is the first time I heard of it.
yeah, I got no result.
Okay, let's do some question. This just summarize for you what we have learned. Strange lah, because I got the impression that even if you don't do the practical, they look at the total mark, that's all. Not like my time. My time, if you don't do the practical, you fail straight away.
Yeah, I think that's about how that's how it works.
Most likely, you didn't ask them for clarification.
I think normal lah because AS paper one uh paper one was quite tricky so.
Okay, if you don't mind repeating. Okay, so these are all that we have learned. Right? Page 303. You won't bother about all this. This one you can okay. Exercise 24.2. Try this one. Attenuation coefficient for bone is 600 per meter for X-ray of energy 20 kilo electron volt. A beam of such X-ray has an intensity of 20 watt per meter square. Calculate the intensity of the beam after passing through 4 millimeter thickness of bone. Right? This is in meter, so you can either change it to per millimeter or change this one to meter, either one. So if we decided to change it to per millimeter, right? This is 1 meter, 1000 millimeter, is 0.6 millimeter, that's your 600. Memorize the formula, right? There's your 20 here, right? There's your 6, there's your 4. Okay, Can
Yes.
explain how hardness of X-ray beam is controlled by accelerating voltage in X-ray tube. Explain how hardness of X-ray beam is controlled by accelerating voltage in X-ray tube. This is the accelerating voltage. Ken, any idea?
Uh,
Hardness depend on energy of X-ray. Right? Depend on the accelerating voltage. Hardness, changing voltage, changes energy. Right? You change the voltage, you change the energy, or you change the speed of the electron. Right? This is kinetic energy. Changing electron energy changes the maximum X-ray photon. It changes this energy. It changes the energy of the X-ray photon. Okay.
increasing the accelerating voltage will increase the maximum photon energy
Photon energy,
and reduces the minimum wavelength makes the
make the
X-ray harder.
wavelength even smaller. Frequency will
Okay.
be large. Frequency will be larger if you increase the accelerating voltage. Frequency larger, so wavelength is inversely proportional to frequency will be smaller. Minimum wavelength, right? Q is energy lost to the target. Okay, not?
Yeah.
Attenuation of parallel beam of X-ray radiation is given by the expression that mu is a linear attenuation or absorption coefficient. X is the thickness of the material through which the beam passes. Anytime will be cut off already. State what is meant by attenuation. Right? Lose of power, lose of energy or intensity. Why is the expression applies only for parallel beam? Intensity changes when the beam is not parallel, decreases when the beam is divergent.
All right.
Okay?
Yeah.
You will have to memorize the formula lah. You can try this one lah. Right? Anytime will be cut off already. So you can try this one.